Welcome to Weekend Academy. Now, in this video, we are going to discuss practice problems in physics. The first one, find the normal force in each of the following. There are two cases given. The first one, 5 kilogram weight block is kept on the smooth floor where the friction is minimum or zero. Okay, in that case, what are the forces acting on the block? And we will have to find out the normal force for this one. See, in the first case, what happened here? No, its weight is acting downward. That is called gravitational force. Fg is called gravitational force. That is acting downward. This is the gravitational force. How do we calculate mass 5 G 9.8, the 5 into 9.8 and 49 Newton. This is the force which is acting downward due to the gravity, and it is called gravitational force. And there is one more force acting, that is called applied force. An applied force of 10 Newton is acting outward. What is the meaning of it? No, the block is pulled in the direction as shown in the figure 30-degree inclined upward, and it is called applied force 10 Newton. This applied force 10 Newton is splitted into two components, mutually perpendicular component. One is this, the other one is here. Here, and this vertical component, it is called Fa sine 30. Fa sine 30 is the vertical component which is acting upward and which is parallel to the normal. So we can call it this. This is the vertical component. We calculate vertical component force is Fa into sine 30. Fa is 10, sine 30 is half, 10 into half 5 Newton. So a 5 Newton force is vertically acting upward. 5 Newton force is vertically acting upward. Is that okay? And now you are asked to find out normal force. So now you connect all these forces. One force is acting downward, two forces are acting upward, one among them is normal. So Fg is balanced by normal as well as vertical component of the applied force, 5 Newton. Therefore, normal is equal to Fg, gravitational force, minus vertical component, that is 49 minus 5, which is 44 Newton. So 44 Newton is the net normal force acting upward. This is 44 Newton. Okay, in this case. Now come to the second case. In the second case, what happens here? The applied force, same, everything is same, but applied force is towards the block. It means in the previous case, pulling. The second case, pushing. We are pushing. So pushing in the sense the block is pushed forward with the force of 10 Newton. Okay. Then the applied force, when we split into two, the vertical component is acting downward. That is that this is equal to how much? This is equal to Fa. This is equal to Fa sine 10. Fa sine 10 in the sense Fa is how much here? 10 into sine 30. That is equal to again 10 into half, which is equal to 5 Newton. The same amount of force which is acting inward. It means downward. Understand? There is a downward force again along with Fg 5 Newton. Is that clear, pa? Here 5 kilogram mass is acting downward due to the gravitational force Mg. That is Mg is 49. We have found already 49 Newton. An additional force of 5 Newton is acting downward due to the pushing effect. Okay, now these two forces are balanced by the normal. So normal is equal to 49. This is equal to how much? 49 plus 5. Why? These two forces are balanced by a single force normal, and hence this is equal to 54. Okay, very easy to understand. In the first case, normal is 44 Newton. Second case, normal is 54 Newton. The option 1 is the correct answer. Recap again here. Both are same weight, but however, the applied force direction is different, opposite. The first case, applied force is no pulling. It means the force is acting outward, and that's why normal is acting upward. In this case, pushing, normal is acting downward. Therefore, normal is added to the Fg. Here, normal is added to the, vertical component is added to the normal. That's why there is a difference. The answer is no first one. Shall we move on to the second one? Right. In this second case, a car travels on a circular racetrack of radius 50 meter, which is banked at an angle theta. If the car travels at a speed of 10 meter per second, wear and tear on its tire is minimum. We are negligible, we discard it. Then the value of theta is asked. The car is moving in a circular track. Here is the car now, right present. The car is here. That's one. Here means the road as we go, take a turn, there is a banking. Banking means we know it slightly elevated on one side. So this elevation angle is theta. Okay. The car's weight is vertically acting downward. That is called Fg. Fg is this. Okay. Fg is acting downward. And there is a normal. The normal is always acting perpendicular to the floor. So this is the normal, and which is asked here. Okay, normal force is resolved into two vertical components. One is a n cos theta horizontal, n sin theta vertical component, which is acting inward. It means it is acting inward. This is called centripetal force. Here centripetal force n sin theta is the centripetal force. Formula for the centripetal force is mv square by r. N sin theta is the component of the normal which is acting towards the center, that is called vertical component. N sin theta is mv square by r, centripetal force. Come to the horizontal component which is actually acting vertically to the mg. Mg is balanced by n cos theta. Therefore, n cos theta, the component of the normal, is balanced by mg, whose weight. Okay, there are two equations right now. So, divide the first one by the second one. What happens here? N cancel. Sin theta by cos theta, tan theta. M by m cancel. And R also, in both the cases of the denominator cancel. Finally, we have tan theta equal to v square by rg. R is not cancelled. M alone cancelled. V square by r by g. That is v square by rg. Tan theta equal to v square by rg is the final result. V 10 meter per second. Therefore, 10 into 10 because meter square. Velocity square. R equal to 50 meter. Then g approximately 10. When you take into account all these things, we get 1 by 5. 1 tan theta equal to 1 by 5. Theta equal to tan inverse of 1 by 5. So the answer is the first one. I go from the beginning again. A car is moving in a circular path. As long the car is moving circular path, the road is supposed to be banked, slightly elevated one side. Angle of banking is theta. At one particular instance, the weight of the car is acting downward. That is called gravitational force mg. Again, a car, since it is on the floor, there is a normal which is perpendicular to the floor. This is the direction of the normal. But the normal, when we resolve into two mutually perpendicular component, n sine theta is acting towards the center of the road, towards the center of the circular road. Okay, that is equal to centripetal force mv square by r. First equation, we got it. And horizontal component of the normal is perpendicular to the road, which is balanced by the gravitational force Fg, that is mg. So n cos theta equal to mg. When we solve these two equations, we are getting theta equal to tan inverse of 1 by 5. Shall we move on to the next question? Third one. An AC voltage V is 220 volt to sine 2 into 10 to the power 3 T is applied to a series LCR circuit. Then the current amplitude in the circuit is asked. See, this is an LCR circuit. What is LCR circuit? You see here, right? And this is an inductor. And then a capacitor. And then a resistor. All the three are connected in series. Okay. To an AC circuit, AC source. And this is it. Here, the inductance of the inductor is 10 millihenry. Capacitance 25 microfarad. This is 100 ohm. Okay, all these three things are given, and the voltage is given here, 220 sine 2 into 10 to the power 3t. This is equal to theta is 2 into 10 to the power 3. This is the voltage. We shall now calculate one by one. XL. XL is equal to L omega. L omega means L is 10 into 10 to the power minus 3. Omega is 2 into 10 to the power 3. Omega is this. Omega 10 to the power 3. Here 10 to the power 3, 10 to the power minus 3 cancel. 2 into 10, 20. Actually, this is in ohm. Okay. Now XC is equal to 1 by C omega. C is 25 into 10 to the power minus 6 because it is microfarad minus 6. And 2 into 10 to the power 3, that is omega. When we simplify, we easily can simplify 25 into 250. 10 to the power minus 6 plus 3 minus 3. The minus 3 when it go to the top, 10 to the power plus 3. But 10 to the power plus 3 means 1000. 1000 by 50 is equal to 20. This is also again 20 ohm. Here XL and XC are equal. Hence, Z impedance is equal to only the R. They cancel and we get only R. R is the total resistance impedance. Then I equal to V by R or V by Z. I equal to 220 volt. R equal to 100. 220 by 100. 2.2 ampere. It is very simple. In an LCR circuit, a straightforward question. Simply we have to substitute the value of L, C and R, and we find out L omega, C omega. Since both are equal, they cancel each other, then only the resistor is left. Then total impedance is to only the resistance alone, which is 100 ohm. Now 220 by 100 gives you 2.2 ampere. This is the answer. Simple. Then we have one more problem for a metal of work function 6.6 electron volt. Which of the following wavelength of the incident radiation does not, see what is asked here, does not give rise to photoelectric effect? Simple question. What is given? The work function is given. What is work function? That is the minimum amount of energy required for a metal to eject an electron. It means for photoelectric effect occur. This is the minimum energy. Only when an incident ray provide this much amount of energy, this photoelectric effect is possible. Here you are given 4 incident radiations whose wavelengths are given. The first caselet 200 nanometer, the second one 150 nanometer, third one 100 nanometer, fourth one 50 nanometer. Which among the 4 does not give rise to photoelectric effect? It means the energy provided by one of the 4 is not enough for producing photoelectric effect. Okay, now for that, what do? We find out the energy of these things wavelength. Here, energy is equal to h nu, where h is the constant, nu is the frequency. Frequency can be written as c by lambda. So, hc by lambda is the formula for finding out the energy of a radiation. Okay, hc, both are constant. When we multiply hc, roughly it comes 1240 electron volt nanometer. That is the unit of this value. Okay, but the wavelength is also in nanometer. That's why we have taken the numerator in terms of nanometer. Only then we can get the answer in electron volt, because electron volt only is given there. Okay, now 200 nanometer wavelength radiation gives how much energy? 1240 by 200, approximately it is 6.2 electron volt. How much energy is required? 6.6 electron volt. But this 200 nanometer wavelength radiation gives only 6.2 electron volt. Hence, this is the one which cannot give photoelectric effect, which cannot give. We shall see the other cases also. In case of 150 nanometer, how do we do? What do we do here? 1240 by 150, roughly it comes around 8.2 electron volt. This is more than the required amount of energy, 6.6, and hence it can produce photoelectric effect. Another case, 100 nanometer. 100 nanometer means 1240 divided by 100, 12.4 electron volt, which is very much higher than the required amount of 6.6 electron volt. Hence, it can produce photoelectric effect. There is another case, 50 nanometer. This wavelength decreases, the energy is supposed to increase. That's what happened here. In this case, 1240 by 50, we get a 25 electron volt, which is much more higher than the expected amount of energy for photoelectric effect. And hence, the answer is the first one does not give rise to photoelectric effect. It is easy to understand here. For photoelectric effect to happen, the incident ray must provide 6.6 electron volt energy at least. Okay, these 4 radiations, out of these 4 radiations, only the 200 nanometer wavelength alone cannot provide this much of energy, whereas all other 3 cases can provide more than the expected amount of energy of 6.6 electron volt they provide, and hence all the other 3 can cause photoelectric effect. Only the 200 nanometer cannot cause the photoelectric effect. This is the answer to this one. And I hope you understood and enjoyed this video. And in the next video, we will come out with many more problems, and I explain in detail. Thank you.